So in looking at our third video on AS integration, we'll be looking at how to work with definite integrals. Now, if we've looked at what we have discussed in previous videos when we first introduced integration, then we can class this as, and what we have been working with, is what we call indefinite integrals. So this is where that when we've got our integral, we have our differentiated function, or our dy over dx function, and we've then integrated that to find the original function. So let's just write original function, and this is our differentiated function. That we have this plus c, where we need to include the constant, which when you've worked to in the opposite direction, or when you've differentiated, if you do have a constant, you lose that constant. Now, when we're dealing with definite integrals, this is when we are actually working out the values contained within that function, that differentiated function. So, and this is what we call a definite integral, and this is where you've got two limits just above your integral. Now, this is your upper limit, which is written on the top, and our low limit is written at the bottom. So when you are working with definite integrals, you lose that constant straight away, and what we then need to do is substitute, put it into square brackets. So this is our integrated function, and we've put that in square brackets because what we then need to do is we then need to substitute our upper limit into our integrated function and subtract that from the value when we substitute our lower limit, or our a value, into the integrated function. Now that is something that's quite important, so it's worth making a note of that in your notes. Now, if that makes absolutely no sense to you at all, do not worry, because when we go through some examples, and we will go through a series and a range of different functions, hopefully it will make sense as to what we need to do. Now, the general sense of this kind of relates to my next video, which is looking at integration 4, where we'll be looking at using integration to find the area under a curve within some given limits of x ordinates. Now, that kind of should really been taught before this, but what we'll do is we'll go through the notion of this because it's really important that you kind of master the mathematics and the notation of definite integrals before we move on to where it's commonly used in the real workplace, or real math place I should say. So let's have a look at some examples to start with. So as an example, we've been asked to calculate the integral of 2x within the limits of 3 and 1, and we're differentiating where 2x has been differentiated with respect to x, hence dy dx. So the first thing we want to do, and I'll write down the steps for this as well, so let's get a different colour pen, so in terms of the method. So step 1, what we want to do is simplify the function inside the integral. Now, with this particular one, I don't need to simplify. It's only a case of if I had brackets, fractions, and roots, then what I want to do is, if I've got brackets, expand them. If I've got fractions, write them using indices, and if I've got roots, write them as indices. And in fact, let me just write that down. So if I have brackets, expand. If I have fractions or roots, write as indices, or using indices I should say. Just get rid of all that. So rewrite using indices. So that should be the very first step that you do. So with this particular question, question 1, I don't need to worry about step 1 because it's basically in its basic form. Now the second step, what we then need to do is integrate the integral. So what I'm going to do from here, let's use a different colour pen, I'll try and remember to switch. So what I then write is I equals, because I'm working out the integral. Now here all I'm going to do is integrate 2x, in which I get 2x squared over 2. Now because I'm working with limits, I put it in square brackets, and I've got the limits of 3 and 1. And what I'm now going to do is simplify that, in which the 2's cancel, leaving me with just x squared and then I've got the limits of 3 and 1. So that is step 2 done and dusted. And again, what we want to do is, just a little note, so write I equals and then use square brackets and don't forget the limits. So once we've done this, I'm now going to kind of, just to keep everything all on the same screen, I'm just going to kind of divide it into 2. So now what we now need to do is substitute. So 3a is sub x equals the upper limit, and then what we then need to do is b sub in x equals the lower limit, and then step 4 is then subtract a from well, I should say subtract b from a. So in other words, you're going to do the answer in a minus the answer for b. So from this, so if I just go through the steps, and let's get the red pen back. So what I'm going to do is I'm going to substitute 3. So if I try and write this in, so I've got 3 squared minus 1 squared. So here what I've done is I've substituted x equals 3, and here I've substituted x equals 1. Let me just make that 3 a little bit neater. And then all I then need to do is simplify, and then step 5 is then calculate. I don't know why I've got a thinner pen. So step 5 is then calculate. So what I'm going to do is have this equal to, so it's going to be 9, take away 1, so the final answer is going to be 8. Now, in terms of presentation of these, it's really important that you set your work out exactly how I've done. Now, in terms of the expansions, things that I would definitely include is I would definitely include this. I wouldn't necessarily need to include this, but I definitely would include this step here and then your final answer. That would be the very, very bare minimum, but personally speaking, I would write down everything just to play it safe. So what I'm going to do is I'm just going to put a highlight around this method, and for the next set of examples I'm going to be following these 5 simple steps to work through, and again I'll be talking you through the range of them all. So let's have a look at the next example. So here what we've got is we've got our integral, and here the key thing I noticed that's different to this question is 1, we've got brackets, and 2, I've got a negative lower term, which again doesn't make an impact. All it does is just increase the difficulty and maybe the amount of marks that are available for this particular question. So if I look at step 1, I'll try and number these in terms as I'm going along so you know what I'm actually doing. So step 1 is, all I'm going to do is I'm going to copy the question exactly how it is, but I'm going to expand these expressions. So if I expand that out, I'm going to get 2x squared minus 10x plus 3x minus 15 dx. Now always make sure that when you've got your integrals you include dx or dp or dt, whatever your whatever your function's been you're going to be integrating with respect to. Always make sure you're writing that d, because examiners will be knocking marks off, and what you don't want to do is be losing marks right to the front, because then it just causes difficulties for you to get marks later on in the question. So once I've done this, I just want to simplify this, so that then becomes 2x squared minus 7x minus 15 dx, and I've got the limits of 3 and minus 2. So now what I can now do is move on to step 2, where I'm integrating. So I equals, and I'm going to integrate each term, so I've got 2x cubed over 3 minus 7x squared over 2 minus 15x. Now I don't need to worry about a plus c because I'm working with limits, and I've got the limits of 3 and minus 2. So now what I want to do, and clearly I've got more space for this, is move on to step 3. And now what I'm going to do is substitute. In one instance I'm going to substitute x equals 3, and I'm going to subtract that when I substitute x equals minus 2 into the function that's inside this square bracket. Now from this, and again I would strongly recommend that you set your work out like I'm doing here. So I've got 2, and then I've got 3 cubed over 3 minus 7 3 squared over 2 minus 15 3, and then I'm going to close the square brackets, minus, open a new set of brackets, because now what I'm going to do is substitute minus 2 in there. So I've got 2 minus 2 cubed over 3 minus 7 minus 2 squared over 2 minus 15 minus 2, and close the square bracket. Now the key thing I just need to highlight because is this. Now when you are dealing with negatives and powers, your first assumption will be to go straight onto your calculator, but just be careful that when you type in on certain calculators minus 2 squared, it will come up with minus 4, which we know as maths sort of learners that when you minus 2 squared means minus 2 times minus 2, and negative times a negative gives you a positive answer. However, what your calculator does is that it's programmed to use BIDMAS. It will square first and then do subtraction. So make sure that whenever you're dealing with negative numbers and powers, that you protect your negative numbers inside brackets going forward. That's if you're using a calculator at this stage. Now personally speaking, I personally wouldn't go reach for a calculator just yet, because what I would do is try and work this out with the simple facts of doing this in your head, or the simple parts of where your calculator could let you down. So what I mean by that is, like, I'm not going to show off and work these out in my head. I'm just going to simplify the things in the brackets. So I've got 2 times 3 cubed. 3 cubed is 27 over 3 minus 7 times 9 over 2 minus, now I can work this out, 15 times 3 is 45, close bracket, minus, then I've got 2 times, now minus 2 cubed is going to give me minus 8 over 3, minus 7, now minus 2 squared gives me 4 over 2, minus, and then this is going to give me minus 30. Now if I was, now I could either go one or two steps. I could either enter this as it's written down exactly onto my calculator, or I can go on to simplify this further using my just common knowledge. So 2 times 27 is going to be 54, so that's 54 over 3. 7 times 9 is 63 over 2 minus 45, minus, and then 2 times minus 8 is minus 16 over 3, minus 7 times 4, which is 28 over 2, and then minus 30 is plus 30, and I close my brackets. So now what I'm going to do is go for my calculator, plug this in there to work it out. Now again, a word of advice, try not to do everything all on your calculator. One thing I would strongly recommend that you do is type in each part separately. Okay, so each of the square brackets that you can see, I strongly recommend that you do that separately. And so that what I mean by that is that you're going to have a number that you fit in here minus a number that you're going to fit in there for you then to work out what your final answer is going to be. So entering that first bracket, I get minus 117 rather, over 2. And if I then enter the second bracket, so I've got minus 16 over 3 minus 28 over 2 plus 30, I get 32 over 3, and if I enter that all into my calculator, so I've got minus 117 over 2 minus 32 over 3, I get an answer of minus 415 over 6, and there is my final answer. Now with these particular questions, although you might think to yourself that looks a bit wrong because it's not quite a nice fraction and we can't simplify, it's not a nice whole number, it doesn't really make a difference. What we want to try and do is make sure that we're doing this correctly, and you could end up with quite some nasty numbers, but key thing is don't write your answers as a decimal. Try and work with fractions where possible, because you want to try and give the exact answer. You want to try and be as accurate as possible. Now if you have got one of the Casio FX991EX calculators, or the one of the graphic calculators, then it will do this definite integrals for you. Unfortunately, it won't do indefinite integrals, but it will definitely calculate the answer for you. So all you'd need to do is basically type in this on your calculator, minus the dx, because you're always working with x, enter the correct limits in the correct order, and then press equals. Now you should, if I'm looking at the FX991EX calculator, that there is a button that looks something like this. Now if you've got a button that looks like this, then all you need to do then is fill in the numbers and press equals, and it will give you this answer straight away. Now the problem with that is, do not do that in an exam, because you will lose all your marks, because what they're looking for is they're looking for each of these steps. So they're looking for you to expand the brackets out, they're looking for you to integrate correctly, they're looking for you to integrate and substitute the upper limit, substitute the lower limit, take it away, and then work out your final answer. Now I've properly broken down the steps, but again, it's so easy for you to lose marks on this particular question by even missing out on a sign, or not correcting yourself, and maybe putting too much faith in your calculators. So it's always worth just double checking and setting your work out like I've done on the screen. Apart from the arrow, always working down just makes things a lot easier for you to process, because it is very, very easy for you to, let's say, assume that -8 squared or -8 cubed is going to give you a positive or a negative answer, or mess up on your signs and go forth likewise. Now in terms of the answers and understanding what the answer means, that will kind of go into more detail when we move on to the next video, where we're looking at area under the curve. But the answer to this particular integral is going to be -415/6. But I certainly would recommend checking your answer on your calculator. So if I do enter what I've written in that green little cloud, using the calculator, type in the correct values, press equals, it should give me the exact same answer as what I get. So it'll turn an exam question into a textbook question where you can check your answers. And also you'll know straight away if you've made a mistake. So let's have a look at question example 3. So here what we're doing was dealing with a show that question, and we've got a square root inside our integral. Now what I'm going to kind of do is ignore the 11/24. I'm just going to treat this question as it is. So let's start off with the first step. So again, I want to rewrite the integral using powers, or using indices. So I've got x to the half dx, and again remembering to write dx. And once I've done that, I can then substitute the values in. So I've got x over 3/2 over 3/2, and I've got the limits of 4 and 1, and that's what the integral equals. Now again, from this, what I can then do now, do I need to simplify this 3/2 as in my denominator? Do I need to move the 2 up like we did in the previous videos? Well, for this, no, you don't. You don't actually need to. So it might make your answer look a bit easier, and if it was on a non-calculator paper, I probably would recommend that you do that. But for this, there really is absolutely no need. So from this, all I then need to do is, this is going to equal. So again, for the first one, I'm going to substitute x equals 4. So I've got 4 to the power of 3/2 over 3/2. Minus, and then it's 1 over 3/2 to the power of 3/2 over 3/2. And what I'm going to do is I'm going to stick that straight into my calculator exactly as it is. Now it can be quite fiddly. Now what you could do is, as this is only a single term integral, I could do all of this in one step on my calculator. But again, take that extra time, okay? Because like I said, doing it all in one go, you might get a mark for working out the value of the first square bracket, you might get a second mark for working out the second square bracket, and doing it all in one go, you run that risk of risking that 2 marks. So 4 to the power of 3/2. Just bear with, I'm trying to get my calculator on point. Divided by 3/2. So that's going to equal, and again I'm just going to break this up, so I've got 16/3 minus, and then 1 to the power of 5 divided by 1.5 equals, and I've got 2/3, and then that will then give me a final answer of 14/3, and there is my final answer. So again, if I plug this straight into my calculator, you should get the correct answer of 14 over 3. And likewise, you can check to see if you've got this correctly by using your graphic or scientific calculator and using the integral function on there. So if I've got the square root of x and I've got the limits of 4 and 1, I'm just checking on the calculator again, it gives me 14 over 3, so I know I've not bodged up there. So let's move on to question 4, or example 4 I should say. So here we've got a mixture of things that I've noticed straight away that makes this question different. So one, I've now got a fraction or reciprocal, and I've also got negative values as my limits, which again is not a problem. Now the key thing to remember is, particularly if you're using your calculator to work this out, is your upper limit needs to go on top. So although 27 is a bigger digit, minus 1 is still the bigger number, so that there is absolutely spot on. So again, what I'm going to do is rewrite this integral. So I've got minus 1 minus 27, and now here I've got x. Now I want cube root, so that's going to be to 1 over 3, and I want the reciprocal, so it's going to be minus, and then I've got my dx. So now I'm in a step where I can integrate. So integrating this, I'm going to increase the power by 1. So here now, another area where a lot of students go wrong is to think, oh, minus a third then becomes positive a third, when actually it doesn't. It's because minus 1/3 plus 1 would actually give me 2/3. So just be careful that when you are adding ones to fractions, just double make sure and try not to get your own common knowledge sort of complacent with the actual answer. So here what I've got is I've got x to the power of 2 over 3 over 2 over 3, and I've got the limits of minus 1 and minus 27. So substituting those in separately, I've got minus 1 to the power of 2 over 3 over 2 over 3 minus 27 2 over 3 over 2 over 3. And if I type that into my calculator, which I'm going to do now, and also gives you time to check and do the same. And stop straight away. And like I said, time waited for me to do this question is a prime example of why it's useful to do each part separately. And if we enter that all in our calculator, we get the answer of minus 12 as a final answer. Sure, that answer was worth it at the end. So again, it depends on just general practice. If you're not great at entering numbers in, and this can be quite fiddly, as you can see, it's very easy to make a mistake, particularly on test conditions. So just make your life a little bit easier and just calculate things separately. So you don't have to be a hero and doing it all in one go. What you could do is work out what minus 1 to the power of 2/3 is going to be. So that's just going to be 1 over 2/3, and then that's that one done, and then minus 27 to the power of 2/3 gives you 9 over 2/3, and then once you've done that, we can then simplify that further if need be, or type that into our calculator, but again you'll get the answer of minus 12. So let's move on to question 5. So again, here we've got a coefficient in front of our function here. So again, what we want to try and do is make our life a little bit easier by rewriting this before we start integrating. So what I've got is I've got 4, and this is going to be x to 1 over 3 dx. Now, if the 4 was inside, so if I had integral of 8 over 1, the cube root of 4x dx, then how that would differ with this integral is that it would therefore become bracket 4x to the third dx. So let's just get rid of this so we're not causing any confusion, and we'll go back to the question. So from this, what I can then do, note that I've changed my colour, got the integral, because I'm now going to integrate. So I've got 4x, and this is going to increase the power by 1, so it becomes 4 over 3 over 4 over 3 with the limits of 8 and 1. And then that then becomes, so now I'm going to substitute my x value, so I've got 8 to the power of 4 over 3 over 4 over 3 minus 1 to the 4 over 3 over 4 over 3. And again, if I just type that into my calculator, either working out separately or not, entirely up to you, in which I'd probably recommend that you practice doing this while you're waiting for me to type in the question. So type that into your calculator, you should get a final answer of 45. So moving on to the next one, so this one's getting more and more complicated, so let's have a look at question 6. So again, the first thing I want to do is try and simplify it where possible. So I'm still going to work with the integral 4 and 3. I've got 2x squared plus 3, and with regards to a fraction I've got x to the half, and I've got a minus dx. So from this, what I've done is I've converted this fraction into, I've put the numerator in brackets. I've then rewritten the square root of x as x to the power of a half, and because I've got a fraction, that's where the minus comes from. Now from this, I want to expand the brackets out, so I've got 4 and 1. Now remember that when you are expanding the brackets, we're multiplying, so here I've got 2 to the power of x to the half. So here I've got 2. Now I'm multiplying the whole term, so it's going to be 2x to the power of, and that's going to be 1.5, or 3 over 2 I should say. Now when you're dealing with the calculator, if you find it easier to work with decimals or work with fractions, it's entirely up to you of how you type it. Because you're using a calculator, that's fine, but just make sure that you're not rounding your decimals up. If it does become a sort of a rational number, where it's a recurring decimal, I should say more, then make sure you use the fraction equivalent. If it's a terminating decimal, then obviously you can use decimals at this particular point. So I've got plus 3x to the minus the half dx. So now it's in this form, I can now go on to integrate it. So I've got 2x to the 5 over 2 over 5 over 2 plus, and then it's going to be 3x to the half over a half with the limits of 4 and 1. So again, substituting numbers in, I've got 4 to the power of 5 over 2 over 5 over 2 plus 4 to the half over a half, and that's the first bracket done, minus, now I'm going to substitute 1 into the function, so I've got 1 to the power of 5 over 2 over 5 over 2 plus 1 to the power of a half. Let's just get rid of that bracket, not that it makes a difference. Over a half. And if I then go on to type that all into my calculator, which I'm going to do right now. Now one thing you could do, and is be a bit sneaky and a bit smart on this, is as you can see I've given the impression that I'm doing the correct thing of substituting the values in. Now one thing I could do is, now that I've written all of this down, is rather than trying to enter that on the calculator, what I could do is just enter this on my calculator, because generally speaking, if I've not made a mistake, it actually might be quicker and a little bit more accurate for me to go in. But I've written down all the steps that the mark scheme would be requiring me to do, so that should be absolutely fine. And if I press equals, I should have the final answer of, just get the correct pen, I should have 154 over 5. And again, that's just being a little bit clever, because you think to yourself, what's going to be quicker? Is it going to be quicker for me to enter this on my calculator, or is it going to be quicker for me to enter this on my calculator? And I would say, as you can see, I've gone through the steps. I've written it using indices and expanded the brackets. I've integrated it correctly. I've given the impression of what you need to do. You need to substitute the upper limit, subtract that from the substitution of the lower limit, and then I've just typed that into my calculator and I've got the answer there. And I also know that at least these two things are going to be correct. And again, because like I said, typing all of this in your calculator is going to be somewhat a challenge for you to get correct first time round. So let's have a look at question 7. So here what we've got is we've got a worded question. So for this, it says for the curve y equals f of x, the gradient function of f of x is 3x squared plus 2. Given that f of x, or f of 1 equals 3, find the value of f of 2. Now this, let's just kind of translate this into questions that we've previously done. So first things first, I've got my differentiated version, so this is my dy dx. And this is what goes inside the integral. So let's have a look. So when we've got, so what I've got inside the integral is 3x squared plus 2. Now from this, what we can then do, we've got dx. Now from this, if I integrate this, so I've got I equals, and it's going to be 3x cubed over 3 plus 2x. And if I simplify that, I'm going to get x cubed plus 2x. Now what this tells me, now this is my f of x, because I've integrated it. Now in terms of the plus c, I won't necessarily need to know that, because obviously it's given me this. Now from this, we know that when x, well, I do need my plus c rather. So when x equals 1, that f of 1 equals 3. So using this, what we're going to do is use this to find c. So we've got x cubed, or should I say, let's get rid of that. So I've got 1 cubed plus 2 of 1 plus c equals 3. So I've got 1 plus 2 plus c equals 3. So c equals 0. So f of x equals, and it's going to be x cubed plus 2x plus 0, which I don't really need to write, but if that did include a number, then that's fine. So therefore, f of 2 is where I substitute 2 into this, so it's going to be 2 cubed plus 2 lots of 2, which gives me 8 plus 4, give me a final answer of 12. So moving on to number 8, and I've got another example left. So here we've got if a to 1 of our limits of 2x minus 1 dx equals 12, find the possible values of a. I'm just going to change this question because I know that I've miswrote it. So I'm going to say find the positive value of a. Now, first thing we want to do is think to ourselves, well, although I've got a bracket, do I need to expand it? Yes, no, it isn't, because it's already in the simplest form. So let's go on to actually work this out. Now, this is basically telling me that when I integrate this with the limits of 1 and a, that the answer is going to be 12. So let's go integrate this first. So I've got I equals, I've got 2x squared over 2 minus x with the limits of a and 1, and that equals 12. Let's make that a look like an a and not a 9 or a g, like so. Now I can simplify this just to make my life a little bit easier. And again, it's entirely up to you whether you want to start rewriting things or work with what's crossed out. But I'm just going to... Oh, don't need that. Minus x a1, and that equals 12. And again, I don't know why my a's look like 9s. So let's just do that correctly, because again, you want to make sure that your handwriting does not make you lose careless mistakes. So going through the steps, I'm going to substitute a equals 1 for a equals a, x equals a. So I've got a squared minus a minus 1 squared minus 1 equals 12. Now if I simplify this, I've got a squared minus a, and then 1 squared minus 1 is just going to be 0 equals 12. Now from this, you think to yourself, let's go on and solve this. So I've got a squared minus a minus 12 equals 0. The other thing what I could do is factorise this like so, but again that doesn't help because there are more. A could be a number of values you could get, although with this particular question it's not too bad. But personally speaking, this looks like a quadratic, so I would actually leave it as a quadratic. So now if I just move this over here, what am I doing? Like so. And I can factorise. I'm just going to write this again so you can see what I'm doing. Now this does factorise, so I've got x minus 4a plus 3 rather, not than x is there. So I've got a equals 4 or minus 3. Now the question's asked me for the positive value of a, so therefore a equals 4. Now the key thing with this is the number of steps that you make, and unfortunately there's no marks written on how many questions this question will be worth, but personally speaking, through my experience, I would say you would get 1 mark for correctly integrating, 1 mark for correctly substituting and making it equal to 12, 1 mark for recognising that it's a quadratic equation making it equal to 0, 1 mark for correctly solving that equals to 0, and then 1 mark for writing and highlighting just the positive solution, which is x equals 4. If I left the answer as a equals 4 or a equals minus 3, I would lose a mark because they're only asking for the positive value due to a last minute change on the question. So moving on to our last example. So again, very similar to what we've done previously, but here we're just looking for values of k. So let's just move that screen up a little bit so we've got a bit more space. Like so. So from this, first thing we want to do is rewrite the integral. So I've got k. Oh, what's gone on there? Gremlin. Right, so let's try again. So I've got k to 1 and I've got 3x to the half dx. Now I know that that equals 14. So integrating this, I get 3x to the 3 over 2 over 3 over 2 with the limits of k and 1, and that equals 14. So substituting everything in, I get, now at this stage I probably would want to simplify again. If I just go for here, let's just make this a little bit easier because it might make my life a little bit easier. So here the 2 then moves that to the front, so that becomes a 6. 6 over 3 then becomes 2, so it's 2x to 3 over 2 with the limits of k and 1, and again that equals 14. So from this I can then substitute 2k to the power of 3 over 2 minus 2 times 1 to the power of 3 over 2, and that equals 14. And if I now calculate this, so I've got 2k to the 3 over 2, which I can't simplify at this stage. 1 to the power of 3 over 2 is just 1, times 2 is just 2, equals 14. I take the 2 over by adding 2, in which if I just move it over here, so I've got 2k to the power of 3 over 2 equals 16. Divided by 2 gives me 3 over 2 equals 8. Now k over 3 over 2 means k cubed square rooted, which gives me 8. Square both sides and I get k cubed equals 64. So from that, k equals 4. And there is our final answer. So it's all about layers, it's all about taking your time, and like I said, although in the screen my answers are all over the place, try and work down in your on your file paper when you're working the exam rather than all over the place, just so it's easy to kind of see what your steps are and what equals what when you're working downwards.